All right, folks, so this video starts our 3 videos on Newton's laws. Newton's first law is where we start, and eventually this is going to be like a blip on our radar on our way to Newton's second law. So let's start. Every one of Newton's laws has like a nickname. This one's called the law of inertia, and we'll explain what inertia is later in the video. The content of Newton's first law is very wordy, so I'll let you copy. You should pause and copy it, and then we can read it. An object in motion will stay in constant velocity motion unless acted on by a net external force. And an object at rest will stay at rest unless acted on by a net external force. So it has 2 parts, and one of the points of the 2 parts is that they're the same idea, that being at rest and being in constant velocity motion, those 2 things have a lot in common. So I'm going to just draw a little chart now. At rest is where we start, and then also constant velocity. Okay, so at rest is velocity equals 0. Constant velocity is not 0, although you can be at rest and have constant velocity. Now, if you are at rest and you stay at rest, then your acceleration is 0. If you are moving with constant velocity and you stay that way, your acceleration is 0. And so Newton's first law basically says that if that is happening, then the net force on you in both situations is 0. So Newton's first law really focuses on finding those moments when the net force on an object is 0. We say a net external force because we want to differentiate between forces within the system and coming from outside. So these 2 phrases, at rest and constant velocity, when you get down to acceleration and force, they mean the same thing. So according to Newton, they might as well be the same thing. It's just a matter of whether it's moving or not. And so this like train of logic goes in both directions. If you are at rest, then there's no acceleration, and therefore there's a net force of 0. But it goes backwards. If there's a net force of 0, then you have no acceleration, and you can either be in constant velocity motion or at rest. So that's the reason for Newton's first law, is to basically identify the importance of situations where the net force is 0 and say that the acceleration is 0 also. If the net force is not 0, then there is acceleration, and we move on to Newton's second law. The other part of Newton's first law is this idea of inertia. So basically, Newton got this law from Galileo, and Galileo had this word inertia that he had defined. So inertia is an object's tendency to resist changes in motion. So inertia is a property of matter, and some objects have more inertia than others, and the more inertia something has, the better it will be at resisting changes in motion. And so the secret here is that this is where force and mass start to interact. Inertia is proportional to mass. So proportional is a very important word in physics, and so now we're talking about 2 things that will change together. So if 2 things are proportional, then when one of them increases, the other one will increase by the same amount. So the more mass that something has, the more inertia it has, and the better it will resist changes in motion. It doesn't mean that very massive objects will automatically have an acceleration of 0 under more situations. It kind of does mean that, but what it really means is the more mass something has, the smaller the acceleration of an object will be in the presence of a net external force. So it's really a way for us to, like, it's a vocab word for us to use to explain why objects behave based on their mass, or why objects behave the way they behave. Okay, the last part of this is just an explanation of something that you will see on your equation sheet. On your AP Physics 1 equation sheet, it says something like, all reference frames are assumed to be inertial unless otherwise specified. So this gives us the idea of an inertial reference frame. So when you observe something, your body, and therefore your eyes, can be in motion or not. And if your body is in motion, then it can be a constant velocity or it can be accelerating. And so depending on the conditions of your body, you can be observing things that are either happening or not happening. And so inertial reference frames are very important for us. And so we don't really need to do much with them, but inertial reference frames are any frame of reference in which Newton's first law holds true. In other words, if the net force is 0, then acceleration is 0. And, so I'll do that properly, sorry, and if the net force is not 0, then acceleration is also not 0. So that's like if Newton's law holds true. That means that if there must be a non-inertial reference frame, and there are definitely situations where, like, you would observe something happen, and if I had you analyze the physics of it, you'd realize that there either had to be a net force of 0, but there was acceleration, or there was there was a net force, but there was no acceleration. And so this is like Newton's law holds true if these things are true. And so this inertial reference frame is any situation where the observer has no acceleration. I will give an example in class for this, but you have observed this happen, where your body is accelerating and you actually observe things in a way that would be very different from if you were at rest or moving at constant velocity. And that's that.